Here we're looking at the warm-up for our 1.5 number 2 set of notes. We're asked to graph the following. Here we have the line y equals 3, and as we know, that's just a horizontal line at y equals 3, so we should see something like this. We have y is equal to x. Well, that's just a line that goes and rises. That slope of 1. And then 1 over x we've seen in the past does something like this. Now, the real reason why we're actually graphing these lines is so that we can start to discuss things as they go to infinity, limits as they go to infinity. Now, we've seen in the past limits as they approach a particular constant, but now we're looking and seeing as x goes towards infinity. Well, if we have the limit as x goes to infinity of 3, so in other words, we're just looking at this first graph, we notice that as you go outwards towards positive infinity for your x values, we notice that that limit is always going to be 3. That's never going to change, much like it is with the constant as x approaches a constant. So as a result, this limit's going to be 3. Likewise, if you go toward negative infinity, that limit is not going to change. It's always going to be 3. For the line y is equal to x, well, when we take the limit as x goes towards infinity, in other words, as we're going out this way for x, we notice that we are constantly going up for our limit towards positive infinity. Whereas if we're taking the limit as x goes towards negative infinity of this function x, so in other words, when we go out this way to the left for x, we see that we're going down toward negative infinity for that limit. Now when we're looking at this graph 1 over x, if we were taking the limit as x approaches infinity of 1 over x, in other words, as we go outwards towards positive infinity for x, we see that it's approaching that limit of 0. Because this thing will just keep going smaller and smaller and smaller. Now when we're heading towards negative infinity, we see that it is also approaching that same limit of 0 for this function 1 over x. So in other words, this is actually going to help us as we're determining some of the computations for our theorem. Anytime you're taking the limit as x approaches infinity of a constant, it's always going to be that constant. Same thing for negative infinity, if you're approaching negative infinity for that x value. For this function, y is equal to x, as you go outwards towards infinity, we saw just a moment ago that it's going to be positive infinity. For this guy, as you go toward negative infinity for that function, y equals x, it's going to be negative infinity. And then same thing for this function. They both approach 0 for their limits. So again, though, that is the warm-up for our 1.5 number 2 set of notes.